Very good morning, students. This question is on the extraocular muscle. Now the question is, describe the origin, insertion and now supply of the extraocular muscle of eyeball. Extraocular means these are the muscles located outside the eyeball and attached to the eyeball. Then they move the eyeball. So they are voluntary or skeletal muscle. The intraocular muscles are ciliary muscles and muscles of iris, constrictor pupillae and dilator pupillae. They are intraocular, but this question is about the extraocular muscles. Okay. Now this question I have just included origin, insertion and now supply. I have not included the action of the muscle, otherwise this question would, the answer would have been very long one. Okay. So I have just only will limit myself to origin, insertion and now supply. For the action, which is has to be understood very seriously, then only you will be able to learn the action of these muscles. Okay, for that I am going to record a separate video for the action. So this is just for the origin, insertion and the now supply. Let us come to the answer of this. The extraocular muscle, as I said, are the skeletal muscles. That means they act as per your will. You can move your eyeball in desired direction. You can look up, you can look down, or you can look towards your nose or outside. Okay. They move the eyeball, okay, in different directions. Thus, okay. These muscles are actually the 6 muscles are there which moves the eyeball. But in the orbital cavity there is also one more muscle here beside this 6 muscle which moves the eyeball, is a muscle which moves the upper eyelid. Okay, though it is not the extraocular muscle, but it is usually taken along with this extraocular muscle because it moves the eyeball and it is in the vicinity of the other 6 muscles. Okay, other 6 muscles. Now there are 4 recti. Why they are called as 4 recti? Because they are ribbon-like, elongated, rectangular in shape. Okay, so these muscles are superior rectus, inferior rectus, medial rectus and the lateral rectus muscle of the eyeball. So these are the 4 recti. Okay, and they are on medial side, lateral side, superior side and the inferior side of the eyeball, attached to the eyeball. But then there are 2 muscles which are obliquely placed. They are running in the oblique direction, not straight in anteroposterior direction, and that's why they are called as oblique muscles. There is one superior oblique and another is the inferior oblique muscle. And another muscle which I said that it will only move the upper eyelid, and this is called as levator palpebral superioris. Levator because it elevates. When it contracts, it pulls the upper eyelid upwards to open the eye. Okay, so this muscle is called as levator palpebral superioris muscle. So there are, thus we are going to learn about the 7 muscles, okay, which are present in the orbital cavity, okay, and are attached mostly to that of the eyeball, and one is attached to the upper eyelid. Now before we go to the origin of the muscle, because this origin of these 4 recti muscles, it is from a fibrotendinous ring or a common annular tendinous ring. Okay, these all 4 recti means superior, inferior, medial and rector. They take origin from the tendinous ring, and this ring is attached to the orbital surface at the apex of the orbit. I will just show you in a diagram where is this apex of the orbit is located. This ring encloses the opening of the optic canal and part of the superior orbital fissure. Thus, within this tendinous ring, fibrotendinous ring, there is the presence of the opening of the optic canal foramina, I mean say canal, not foramina, and the part of the superior orbital fissure is also enclosed by this. Let us see this in the diagram. Okay, we have already covered this. I mean say structures passing through the superior orbital fissure in the previous videos. Okay, now see this is the superior orbital fissure. Okay, and then to this superior orbital fissure, which is bounded superiorly by the lesser wing of the sphenoid, and below it is bounded by the greater wing of the sphenoid, and on this medial side, this is the area for the body of the sphenoid. So from the body, lesser and greater wing of the sphenoid, they run laterally and encloses an elliptical fissure here, okay, which is called a superior orbital fissure. Now just above this superior orbital fissure and little medially located is an optic canal through which comes this optic nerve. In yellow color I have shown the optic nerve which comes in from the middle cranial fossa, and just infralateral to it is the presence of the ophthalmic artery. So covered by the dura mater, arachnoid and pia, this optic nerve are covered. Okay, this optic, this ophthalmic artery is within this, okay, enclosed within this membrane as it runs in the eyeball. Okay, after this coming out from this, the optic canal. Now, enclosing this optic canal which contained the optic nerve and the ophthalmic artery, enclosing a part of the superior orbital fissure, there is the attachment of this fibrotendinous ring. And from this fibrotendinous ring, which is attached to the apex of the orbit, okay, these four muscles or four recti, they take origin. Superior rectus, the medial rectus, the inferior rectus and the lateral. This is the site of origin. So this origin is from that fibrotendinous ring. Above this, there is a separate from the lesser wing of the sphenoid. This muscle is taking origin which will go to the upper eyelid, levator, palpebral, superioris, and the medial and superior to this ring. This is the superior origin of the superior oblique muscle is here. So these are the 6 muscles. The 7th muscle is the inferior oblique muscle, and it is the orbit. This is the nasal aperture, nasal bones and maxillary frontal process of maxilla is here in this diagram. The inferior oblique takes origin from the base of the orbit, that is near the opening of the orbit, from the infromedial angle, okay, which is just close to that of the lacrimal fossa. And this muscle, after taking origin, it runs near the floor of the orbit, though I could not draw it as looking as it is floor. This muscle runs very close to the floor and the posterolaterally. This is the inferior oblique. Thus there are the 7 muscles of the extraocular muscles are there. Try to see these muscles in this. This is that fibrous ring, okay, annular linked fibrotendinous ring, and from this the 4 recti are taking origin. This is the superior rectus, okay. This is the lateral rectus, and deep inside it is the medial rectus is there. So lateral and medial recti are there, which are inserting just few millimeter behind the limbus, that is the sclerocorneal junction is here. Okay, this is the inferior rectus muscle, and then this is another muscle which was here, superior rectus muscle, superior oblique muscle, and this superior oblique muscle will just take a turn, okay, around a pulley which is attached near the medial superior angle of the orbit, okay, near the orbital opening or the base, and then this tendon will take a turn and will run backwards and laterally on the superior surface of the eyeball. Similarly, this 7th muscle, the 6th muscle, this is which is taking origin from that of the medial angle near the floor is the inferior oblique muscle, and this will attach also onto the eyeball. The 7th muscle is the levator palpebral superioris, which is not going to the eyeball but it is going to the lid, superior eyelid, okay, where it is inserted. Okay, so these are just an introduction. I will come back again to this diagram when I will take the individual muscles here. Now I will show you this diagram just for your orientation, and then I will go to the origin, insertion and the nerve supply. Let us see here from this dissector. I will show you this muscle. This is the theme dissector, authored by me for this volume of Head and Neck and Brain and published by the theme. I am thankful to them for using this. Let us see this. Okay, just a minute. You see this orbit, okay, from where this a tendinous ring will be attached. If you can see, this is the superior orbital fissure and this is the optic canal is here, enclosing the part of the superior orbital fissure and opening of the optic canal. There is the attachment of the fibrotendinous ring, and this is the site where the apex of the orbit is located. So this is that fibro from where the four recti, superior, inferior, medial and lateral recti, they will take origin. Okay, they will take origin. Now about the origin of the superior oblique. Superior oblique is attached here somewhere, okay, supromedial to that of the optic canal here, and here on the lesser wing of the sphenoid is the attachment of the origin, I mean to say, levator palpebral superioris is there. Now this is the floor, and the floor at this inferior angle of the infromedial angle of the floor here, close to this lacrimal sac groove, there is the origin of the inferior oblique which will run backwards and laterally to go to the eyeball behind the equator, as we will see just now. And this diagram will show you about the attachment of the pulley. Okay, this is the medial wall of the orbit. This is the lacrimal bone is there and lacrimal fossa is there, and this was the site from where the origin of the inferior oblique takes place. Similarly, here in the trochlear depression or fossa, where the trochlea, okay, pulley is attached for the tendon of the superior oblique, and this from here the tendon will change its direction and will go backward and then towards the lateral side. So this is that site of attachment of that pulley, around which the tendon of the superior oblique will take a turn and will change its direction will change. Let us see with this help of these diagrams about this muscle as they will look. Okay, this will give you a fairly good idea that this is the limbus, that is the sclerocorneal junction, and few millimeters, say about 6 to 8 millimeter behind, that is the attachment of this muscle, superior rectus, lateral rectus, medial rectus, and this is the inferior rectus. And here you can also see that the origin of the inferior oblique muscle, which is going backwards and laterally. See this is going deep to the inferior rectus. This is inferior oblique. Similarly, you can see here that this is the pulley through which the tendon of the superior oblique is taking turn and then going backwards and laterally, okay, backwards and laterally. This diagram will also give you a fairly good idea about the direction of the muscle. See, this is the near the medial wall of the orbit. This is the superior oblique muscle, and this is that trochlea or the pulley winding round to this pulley. This is sorry, this is the tendon of the superior oblique which will go deep to that of the superior rectus muscle, and this muscle which is cut here is the levator palpebral superioris, which will go to the upper eyelid. This is the lateral rectus, and here is the medial rectus. Inferior rectus is seen in part, okay, this is the inferior. So those are the four recti. One levator palpebral superior is a superior oblique, and inferior oblique is not shown in this diagram, but it is well seen in this diagram. I hope that you must have got an idea about the muscles, recti, as well as the oblique eye of the eyeball. Let us come now to the our question where it was the about the muscles. Let us come about the origin of the four recti. So we come about the origin of four recti, that means superior rectus, inferior rectus, as well as the medial and lateral rectus. All these four recti, they arise from a common tendinous ring, as I said, and this ring is attached to the orbital surface of the apex of the orbit. This ring is enclosing the opening of the optic canal and part of the superior orbital fissure. Okay, let us see this diagram for superior rectus first. Okay, if you see this superior rectus in the separate diagram I have shown, this is the eyeball, this is the equator of the eyeball, this is the medial wall, that means nose is here somewhere, see this, and this is the, that means we are seeing the left eyeball from superior view, and this is the direction after taking origin from the fibrotendinous ring near the apex of the orbit. This muscle is running forwards and a little laterally, and then it is inserting here about 6 millimeter behind the this sclerocorneal junction, which is also known as limbus. Okay, so about 6 millimeter. This is inserting onto the sclera, which is a tough I'm to say fibrous membrane, I'm to say layer of the eyeball, which is made up of the inelastic collagenous bundles, okay, the sclera. So the muscle, so origin is bony, I mean to say not bony exactly, from the fibrotendinous ring attached to the apex, bones of the apex, and then insertion is onto the organ, okay, that is the eyeball. Okay, so this is the muscle which is the superior rectus. So see the direction, see this is the medial wall, and see the direction of this muscle. Similarly, if you see the inferior rectus, it also takes origin from that of the fibrotendinous ring, as it is seen here. This was the superior rectus going here, then this is the from fibrotendinous ring, this is the inferior rectus going and attached to the limbus. So this is in dotted line shown because it is going below, okay, the orbit, okay, in this left eyeball, to which we are seeing from the top. Okay, then medial and lateral rectus. Okay, this is the lateral rectus muscle, as we are seeing this from the lateral side, and hidden behind it, this is that medial rectus muscle. They will also be inserting somewhere between 6 to 8 millimeter behind that of the sclerocorneal junction, that is behind the limbus on the sclera. So these are the four recti which are taking origin from fibrotendinous ring near the apex of the orbit and going to that of the eyeball anteriorly. But the direction of this muscle is important, especially superior and the inferior. Both have the same direction. But the medial and lateral rectus, okay, again the left eyeball, this is the medial side, and we are seeing from the top. The medial and lateral, they lie on the median and lateral side of the eyeball. Okay, they lie from the medial and lateral side of the eyeball. So I hope you have understood the origin of this muscle. Let us come to the insertion of these four recti. The insertion of these all four recti, they are inserted into the sclera, as I said, a little posterior to the limbus or the sclerocorneal junction. Okay, the average distance, which I already mentioned, that is from the limbus backward, okay, that is from sclerocorneal junction, it is 8 millimeter for superior rectus. That means superior rectus is attached to the sclera 8 millimeter behind the sclerocorneal junction. The lateral rectus is 7 millimeter behind, the medial rectus is 6 millimeter, and inferior rectus is about 7 millimeter behind the sclerocorneal junction. So this is the origin and insertion of the four recti. Now let us come to the origin of superior oblique muscle. Now this superior oblique muscle, it arises, let us see in this diagram first. Here it arises from that of the bony origin, and then it runs very close to that of the medial wall of the orbit. Okay, superior, see here in this diagram, just a minute, this is very close to the medial wall of the orbit. This is the origin of the superior rectus muscle, which arises from the body of the sphenoid, and then it runs forwards, okay, and then it will be just near the orbital opening, near its superior angle where the trochlear pulley is there, the tendon will be just taking the round, okay, it will be passing. So tendon will pass through the fibrocartilaginous pulley. It is a fibrocartilaginous pulley, not pure fibrous pulley attached to the trochlear fossa of the frontal bone, which I have shown you in that diagram. That is, there is a depression, what is called as trochlear fossa, where this pulley is attached near the supromedial angle of the orbital opening, okay, very close to the orbital opening. And then this tendon will wind round the pulley to change the direction. Now it means now after this postero-anterior direction, then it will change the direction, and then this tendon will go, okay, I mean to say laterally, downwards and backward. It will go laterally, downwards. See, this is the lateral side here. This is the lateral side. After running anteroposteriorly from the pulley, the tendon will change its direction, will go laterally, posteriorly and downward. Downward means what? Okay, downward because the pulley is here at near the roof of the orbit and eyeball is below. So it has not only to go in the posterolateral direction, but it has to go in downward direction as shown in this diagram. Okay. Now, and then insertion is on the sclera. Now, if we are seeing the eyeball from the top, divide it into 4 quadrants behind that of the limbus or sclerocorneal junction, then the insertion is in the outer and posterior quadrant, that is posterior. On lateral side, this is the posterior and outer quadrant, lateral quadrant, okay. That means behind the equator, okay, behind the midline, behind the equator, this tendon is attached, okay. This, remember this, it is very important. When in the next video I will discuss you about the action of this muscle, this insertion and its direction will play an important role, okay. Now, after this origin of superior oblique, let us come to the origin of the inferior oblique. Now, the oblique takes origin from anteromedial angle of the floor of the orbit. Supromedial angle was the pulley was there for superior oblique, and the same place but near the floor, okay, the same direction it will take muscle. Angle of the floor of the orbit, it is the attached, and then lateral to the opening of the nasolacrimal canal, okay, that was a groove for this lacrimal sac, and then below that there was a canal, nasolacrimal canal is there where you can pass the probe. Just very close to it, lateral to it, there is the origin of the inferior oblique from the floor, and then this muscle will run, okay, posterolaterally below the eyeball, okay. So then insertion will be on the lateral part of the, let me show you where it is the insertion. With this diagram you may get some idea that after taking origin from the medial angle of the orbital opening near the floor, this muscle is running infrolaterally, okay, that means laterally and backward, and then it will come onto the lateral aspect of the eyeball, very close to the lateral rectus, okay, very close also to the insertion of the superior oblique. So both the muscles will attach onto the lateral quadrant, and then these two insertions, that is of superior oblique and that is of inferior oblique, they are close to each other, deep to that of the lateral rectus muscle, deep to that of the lateral rectus. While this inferior oblique is running near the floor of the orbit, it is running deep to that of the inferior rectus. But when this superior oblique is running towards the posterolateral direction, it is running deep to the superior rectus. Here it is running deep to the inferior rectus. That means this is running superior oblique between the muscle, superior rectus, and the eyeball. Here it is running between the floor and deep to the inferior rectus. That you should remember about the origin and insertion of the superior and the inferior oblique of the muscles. Let us come to the another muscle which is called as the levator palpebral superioris muscle. Okay. Now this will take origin from the undersurface of the lesser wing of the sphenoid, just above this apex. Okay, where this fibrotendinous ring is attached. See this here. This is the site of the attachment of the levator palpebral superioris. This was the attachment of superior oblique from the body of the sphenoid. Okay, and this was the supromedial, and this is just directly superior to that of the orbital canal. I mean, say the optic canal. Okay, after taking origin, okay, the opening of the optic canal just above it, then this muscle will run forward. Okay, just below the roof. In the middle part of the roof, it will run, okay, deep to the roof of the orbit, straight forward, and then when it will approach to the orbital opening, then it will splits into 3 slits. One of the slip will go to the skin of the upper eyelid, and middle slip will go to the tarsal plate in the eyelid, and the posteriormost slip will go to the conjunctival sac or to the mucous membrane. So when this muscle will contract, it will elevate or lift the upper eyelid, as in the opening of the eyeball. Okay, I mean say in the opening of the eye, the lids goes upward. So this is the muscle called as the levator palpebral superioris. Now let us come to the nerve supply of these muscles. Okay, nerve supply of this muscle will be that the superior oblique, this muscle, okay, it is supplied by the, here I will write down as a 4th cranial nerve, that is trochlear. 4th, it is supplied by the 4th cranial nerve. CN means cranial nerve. So this is supplied by the 4th cranial nerve, while the lateral rectus, which is here, see this, we are seeing this diagram from lateral side. So this lateral rectus muscle is supplied by the 6th cranial nerve, that is the abducent, 6th cranial nerve. So 4th cranial nerve and this is the 6th cranial nerve. They are supplying to that of the superior oblique and the lateral rectus respectively. Okay, the rest of the muscle, including the levator palpebral superioris, superior rectus, the medial rectus, the inferior rectus, and then this inferior oblique. Okay, this remaining 5 muscles, they are supplied by the oculomotor nerve. There will be 2 divisions of oculomotor nerve, superior and inferior division. So the superior rectus, inferior rectus, medial rectus, inferior oblique and the levator palpebral superioris, they will be supplied by the oculomotor nerve. Okay. Now I hope that you have understood the origin and insertion and the nerve supply of these extraocular muscle. Thank you very much for watching this video.